Hello students, in this video we are going to discuss Cbse class 11 Maths chapter 4 complex numbers and quadratic equations. In this video we will be discussing the concepts, the first few concepts in this chapter. Okay, so now we will learn about what are complex numbers in this video. Now before we get into the complex numbers, we'll just do a quick recap of the number system which we learned in class 9 and 10. Okay, so what did we learn about number system? We saw that first we had the natural numbers and then we had the whole numbers, and the two all together along with the negatives we call them as integers. Okay, and then we had two other classification, rational and irrational numbers. So what did we call rational numbers as? Terminating, or it is going to be repeating. So in such kind of decimals will come under rational numbers, and if a decimal is going to be non-terminating and non-repeating, then we call them to be irrational numbers, and we brought all these numbers under one big category called real numbers, which you learnt in your class 10. Okay, so in your class 10, if you remember, it was the first chapter in your textbook. Okay, so this is regarding whatever we learned till now. But when we found out the roots, of the quadratic equations and all, we were able to say that when your b square minus 4ac was less than 0, then we said that the roots are not real. The roots are not real. So that time we also said that it is not real, so it is something else. Okay, so those things, if it is not real, then what will you call it as? It is going to be imaginary. It is going to be imaginary. All these concepts, the basic concepts, are already discussed in class 9 and class 10 videos also, children. If any of you are still having doubt with these concepts, please get back to those videos and try to understand them once again. Okay, so if it is not real, you call them as imaginary numbers, and these complex numbers are those which deal with these kind of imaginary numbers also. Okay, so that is what we are going to see about. So before we get into all this, see, you can see a lot of I here. Everywhere you have I. So complex numbers, if you see, I is an important thing which will be there. Okay, so we'll just get to learn what is all this and how we are getting to learn about the complex numbers. So before we learn about it, we are going to do this question: y is equal to x square minus 1. So what kind of an equation is this? So this is going to be a polynomial, and the degree of the polynomial is going to be what? 2. So if the degree is 2, you call it to be a quadratic equation or a quadratic polynomial. Okay, now for this polynomial, let us substitute different values of for x, and then we'll find out the value of y, and we'll try to plot it here. Okay, before that you would have learnt about the zeros. So all that we'll be finding out by getting the graph. How we'll get the graph for a quadratic polynomial? It is going to be a parabola. All these you would have learnt in the polynomials chapter in class 10. Okay, so now let's get into the finding out the values of y. Okay, so if x is going to be 0, the value of y will be what? 0 square plus 1, so it will be 1. If x is equal to minus 1, y will be minus 1 the whole square plus 1, which will be 1 plus 1, 2. So what will be x equal to 1? Y is equal to 1 square plus 1, 1 plus 1, which will be 2. For x is equal to minus 2, y is equal to minus 2 the whole square plus 1, which will be 4 plus 1, you will get 5. So for x equal to 2 plus 2, y is equal to 2 square plus 1, so which is going to be 4 plus 1, which is going to be 5. So now we'll substitute the values. For x is equal to 0, your y value is going to be, so this is your 0. For x equal to 0, y value will be 1. So it's going to be here. Okay. And for x is equal to minus 1, your y value is going to be 2. For x is equal to plus 1, your y value is again 2. For x is equal to minus 2, your y value is going to be 5. And for x equal to plus 2, again your y value is going to be 5. So now your graph is going to come like this. So this is your graph. So you can see that you have got a parabola open upwards. So it is going to be a parabola. So have we got it? Yes, we have got it. Now the next thing is going to find out the zeros. So we are going to find out the zeros. How will we find out the zeros, children? So for finding out the zeros, we will have to see where this parabola is going to cut the x-axis. Okay, so wherever it cuts the x-axis, then we will get. For example, if we have got a parabola like this, then we will be getting 2 zeros here. But look into this graph, you can see that it does not touch the x-axis at all. So in this case, so if you look into your class 10 textbook, it is there in your case 3. Okay, in the polynomials chapter. So in that you can see that, so under case 3 you can see that if it is going to be upwards, okay, upwards or downwards without touching the x-axis, then we can say that there are no zeros. There are no zeros. But it is a quadratic polynomial, the degree is 2. So if the degree is 2, it means that there should be 2 roots. There should be 2 roots. But it is not possible. Here this is going to be contradicting. So it means there is going to be something. Okay, there is going to be some other value. That is what we are going to check for it. Okay. Now, so without going to this, let us do with this equation. So here it is of the form ax square plus bx plus c. A quadratic polynomial should be of the form ax square plus bx plus c. So in this case, your a is going to be 1, your b is going to be 0, your c is going to be 1. So what is your b square minus 4ac? It is going to be, b square is 0. So 0 square minus 4 into 1 into 1. So what is the value now? It is going to be minus 4. It is going to be minus 4. If it is minus 4, then it means that there are no real roots. There are no real roots. So if there are no real roots, it means there is something wherein you can say that is going to be imaginary. How do we get that? So when you arrive at this case, we are saying that there are going to be imaginary roots. So imaginary roots are going to be got in another plane. We are going to consider a third plane. Okay, a third plane which you will get when you are going to just extend it. Okay, so you can see how it is going to get extended. So when you are going to get extended, you can see that it is going to come to a third plane where now this is going to cross the x-axis. So at this point you are going to say that it is going to cross the x-axis. So now you can say that it crosses some point here wherein you can say that we are getting the 0. See, you can see this is our graph. Okay, see this is the graph which we drew, and we are extended towards the third axis. Then you can say that it is going to cross this plane. Okay, it's going to cross the x-axis, and thus we are getting the roots, and these roots are called as complex roots. Okay, so you can say that they are going to be complex. So this is only as simple as it, children. Okay, I am telling this so that you will understand why complex, because most of you may continue learning this without even understanding what is this complex and why we are using this I and not. Okay, for that only I have done this. Okay, so you can see here, you can see this is there. So you have all these values here. So this is going to be the graph. So this was our graph. So this was our graph which was created. Okay, so like this we had our graph, and then we saw that it was extended here, okay, on this side. So thus we got these roots. So how we are going to calculate it and all that we will be doing it later. Now I just made you understand the concept of these complex numbers. Okay, so now we are going to see that whenever you represent a complex number, see, you had two axes. Let me take, this is going to be A, and if this is going to be B, okay, you're only shifting this somewhere here, and then you got the value. So that is going to be an imaginary part. Okay, so it will be I into B. So when you are going to represent complex numbers, you will represent it as A plus IB. So any number you take, see here, so we know these are going to be natural numbers, these are going to be integers, and these are going to be your rational numbers, real numbers, and then these are the complex numbers. Okay, so now you are going to represent it with an I. So here you can see it is of the form A plus I into B. Here do you have anything here? No, you only have I. So it means that there is only an imaginary part, and the real part, A is going to be 0 and your B is also going to be 0. So there is only going to be I. We will see the value of I now. Okay, children. So now what is this A plus IB? So when you are going to represent complex numbers, you are representing it in the form A plus IB, where A and B are going to be real numbers. A and B are going to be real numbers. So we are representing the complex numbers by Z. So complex numbers are going to be 8 minus 2i, 2 plus 31i, 2 plus 4 by 5i. Any way you can represent. You just need to remember that this and this are going to be real. Okay. Now, if you are going to consider some value x square is equal to minus 1, and you are going to take the square root of it, you are going to have square root of minus 1. Do we know the value of root minus 1? We do not know. Only when we came to that kind of case, we said that it is not real, because your b square minus 4ac, when it is going to be negative, so in our x square plus 1, we got the value to be minus 4. So when you substitute in the formula, how will you get for the roots? For the roots, you will get it like minus b plus or minus root of b square minus 4ac by 2a. Okay, so you'll get it as plus minus b plus or minus root of b square minus 4ac by 2a. In that case, when you substitute here, you will get it to be square root of minus 4. How can square root of minus 4 be written? Square root of minus 1 into square root of 4 into square root of 4. So you can write it as 2 into root minus 1. So now for this root minus 1, we do not know an answer. So that is your I. Have you understood, children? So I is nothing but I is equal to square root of minus 1. So if you are going to have 8 minus 2i, okay, so then that means the value is going to be 8 minus 2 root minus 1. That is what you are representing it as I. Is it clear, children? So for this, you are going to represent A as the real part of Z and B as the imaginary part of Z. Okay, because B is what? Along with I, you represent it as the imaginary part of Z. Okay, so if you have something like 2 plus I5, then real part of Z you will write it as 2 and imaginary part of Z you will write it as 5. Okay, so now when you have two complex numbers to be equal, how will you say that they are equal? It means when you have A plus IB and C plus ID, if A is equal to C and B is equal to D, then you can say that they both are equal. So A should be equal to C and B should be equal to D. In that case, you can say that these are equal. See, to sum up in short, I am just telling you one main thing you need to remember is that I is equal to square root of minus 1. Whenever you have the minus under the root, you remember that you will have to use the concept of complex numbers. So this is very important even in your physics also. Okay, so you will come across all these when we are doing like vectors and all in physics and all. You will be able to understand. You would have learnt about scalar quantities and vector quantities and all in physics in your class 9 itself. So when you're going to implement all that, you will come across I. So remember children, here you have, see here, 5 plus root minus 15. How will you write this as 5 plus 15I? Is it clear children? So this is your complex number. For this, what is the real part of z? It is going to be 5. The imaginary part of z is going to be 15. That's all children. It's very easy, okay? So this is how you will have to remember and you will have to do. So this is all about your complex numbers. We are done with the introduction of the complex numbers. So in this graph you can see. So this is how they are represented graphically also. All that will be seeing slowly one by one. Okay, we have a lot of concepts under these complex numbers, but they are very simple. So don't think that it's going to be difficult topic and all children. It's very easy to understand. Please go through the concepts carefully so that it will be easy for you. See you again in the next video with the next few concepts from this chapter. Thank you children.